Hello students, in this series I am going to discuss about energy. Here is the first part of energy. In this part I will give you notes on what is energy, units of energy, different kinds of energy. In different kinds of energy I will mainly discuss about the mechanical energy. So let's start. Energy. How you can define energy? In very simple way, you can say energy is the capacity or ability to do any work. It exists in different forms such as potential energy, kinetic energy, thermal energy, electrical energy, chemical energy, nuclear energy, and so on. When we study about energy, then we need to understand work done also. I will make a separate video related to work done. But now you just remember what can be said for a work done. In common day-to-day life, we can say work is any kind of activity that requires a physical or mental effort. But in physics, we have a particular definition for that. We can define work as any kind of force which causes a displacement in an object. Or you can say if a force displaces an object, then work is said to be done. It can be calculated with the formula force into displacement. It has a unit joule. Now let's see the units of energy. Here the SI unit of energy is joule, whereas CGS unit of energy is erg. And in MKS system, the unit been taken as joule again. But in different places with different contexts, we use different units also, such as British thermal unit, horsepower, kilowatt hour, calorie, electron volt, etc. Here you can see there are some relation between the SI unit of energy with other common units. For your examination, one question is very important. Define the SI unit of energy. To define the SI unit of energy, you need to remember you have to go for joule. 1 joule of energy can be said to be as the product of 1 Newton of force with 1 meter of displacement to the body on which the force been applied and the body been displaced in the direction of the force applied. So you can say 1 Newton into 1 meter is equals to 1 joule of energy. Now let's understand the different forms of energy. Before we go for different forms of energy, we need to see the first law of thermodynamics. You will understand about thermodynamics in your higher classes. Thermodynamics is a part of physics which deals with the study of energy. Now, the first law of thermodynamics is also known as the law of conservation of energy. According to this law, energy can't be created nor be destroyed, but it can be transferred from one form to another form. Thus, you can see so many different forms of energy. Here you can pause the video and name out all the forms of energy which you can see on the screen. As just now we had discussed that there are so many different forms of energy because energy has a tendency to be transferred from one form to another form. Therefore, we have light energy to heat energy, then to electrical energy, sound energy, chemical energy, and so many. But when we classify or specifically study about the kinds of energy, then we come to know about kinetic and potential energy. Kinetic energy is the energy in a moving object or mass, which includes sound energy, thermal energy, electrical energy, etc. Whereas potential energy is any form of energy that has a stored potential that can be put to future use, which includes nuclear energy, chemical energy, etc. I will explain about all these forms of energy in a separate video. Now, let's understand these two basic forms of energy as kinetic and potential energy. Here we have kinetic energy. What is kinetic energy? Kinetic energy is a form of energy that an object or particle has by reason to its motion. If work which transfers energy is done on an object by applying a net force, the object speeds up and thereby gains kinetic energy. You can also say that kinetic energy is a property of a moving object or particle, which depends not only on the motion but also on the mass of the body. Now, let's understand how to calculate kinetic energy. The kinetic energy of a moving body with a certain velocity is equal to the work done on it to make it acquire that velocity. The kinetic energy possessed by any object of mass m and moving with a velocity v can be calculated with the formula half mv square. Now you can see some of the forms of kinetic energy. Remember, earlier I said that sound energy, electrical energy, etc. are the types of kinetic energy. They are kinetic energy because they also causes due to motion. Here, the forms of energy which you can see for kinetic energy, that is due to the path of motion. So here, translational kinetic energy, rotational kinetic energy, vibratory kinetic energy is due to its different kind of motion, such as translatory kinetic energy is the energy of a body for a motion which occurs in a straight line. Rotational kinetic energy is the energy in a body due to the rotational motion, whereas the vibrational kinetic energy is due to the vibrational motion. Now let's understand about potential energy. How we can define potential energy. The potential energy possessed by any object is the energy present in it due to the position or its configuration. Potential energy is the energy that is stored or conserved in an object or substance. This stored energy is based on the position, arrangement or state of the object or the substance. Now, let's understand how to do the calculation of potential energy. Before we go for the calculation of potential energy, we need to keep it in our mind that potential energy of a body is the energy that has potential to do some work. That's why chemical energy, nuclear energy, etc. are been taken as the types of potential energy. But when we go for the calculation of potential energy here, we will go for its two forms, that is gravitational potential energy and elastic potential energy. Out of this, the elastic potential energy I will explain when I will make a separate video for higher secondary students. Here, we need to understand the gravitational potential energy only. The gravitational potential energy of a body is the stored energy due to change in its position from the Earth's surface. Thus, its formula can be mgh, where m stands for the mass of the object, g stands for the acceleration due to gravity, and h stands for the height from the ground surface wherever we had taken the zero potential. Now, let's see some of the difference between the kinetic energy and potential energy. For a kinetic energy, energy due to motion, whereas for potential energy, it is the energy due to change in position. Kinetic energy can be transferred between objects, whereas potential energy can't be transferred between objects. It is measured from place to place, whereas potential energy measures from the bottom. For kinetic energy, it is relative to the environment of the object because motion is related over there. Whereas potential energy, it is not relative to the environment of the object. We can calculate the kinetic energy of a body with the formula half mv squared, whereas we can calculate the potential energy of a body with the formula mgh. Here you can see two of the examples where the kinetic and potential energies are coming together or correlated. Mechanical energy. When we study about kinetic and potential energy, then mechanical energy is a very important factor over there because mechanical energy is the energy that is possessed by any body due to its motion or its position. And just now we had understood this thing that the energy due to motion is known as kinetic energy, whereas the energy in a body due to its position is known as potential energy. Thus, if a body has kinetic energy or potential energy, then it is also having mechanical energy. The object having mechanical energy if they are in motion or if they are at same position relative to a zero potential energy position. Here you can see some of the examples where kinetic and potential energy in a body been given. So you can pause the video and go through these examples. Here are some other forms of energy also, such as heat energy, light energy, chemical energy, sound energy, mechanical energy, electrical energy, atomic energy. I will explain about all these forms of energy in a different video related to each of them.